In the second part of the lab, we're going to look at how resistance combines in a circuit. So when you have multiple sources of resistance, how do they combine? Looking at parallel versus series combinations. Now, before we get to the data collection part, I just want to do a quick demonstration of this. So I have a battery, and that battery can provide current, and we have light bulbs here that we can potentially light up. So if I touch that to that, I can get the light bulb to light up. Now, let me connect one end to one light bulb, and then I'm going to connect them in series. So I'm not really using the meter here, but I'm going to go from one light bulb to another. And then why don't we go from another light bulb to another light bulb. And so we're going to essentially have three resistors in this circuit. We have three light bulbs. Okay, so current can go from, or let's see, this is the negative terminal. Electrons can come from here, go through the light bulb, heat up the filament, make it glow, heat up this filament, make it glow, heat up this filament, make it glow, and then return back to this terminal when I complete the circuit. And so all three light bulbs should light up. And because it's one continuous path, they all have the same current going through them. The series combination of resistors adds together the resistance. So one of them by themselves would have smaller resistance, meaning more current through the circuit. Multiple resistors means lower current in the circuit. And so all three together glow this bright. So you can see how bright they glow, just the three of them. If I were to take out one of them, take one out of the path, I'm lowering the amount of resistance that the current has to go through. And so these two should be brighter than just the three were. So now I have more current in the circuit because there's lower resistance. And I lowered the resistance by taking out one of the resistors. They just add together in series. Now let's just look at two at a time. So we saw how bright it is with two light bulbs. Right, so there's two light bulbs in the circuit in series. Now let's put them in parallel. So in order to put them in parallel, what has to happen is the current that goes into this one has to split. So the current that goes into either of them, it splits before it gets to them. I'll take my wire back here. And so we go electrons coming from the negative terminal to here. I'm going to connect this to that. And so now the current can split at this point. Some of it can go through this light bulb, and the rest of it can go through this. And so now I'll have two light bulbs in the circuit, but a different total resistance. So now the current has two paths to go through. And because of that, I've got a lower resistance environment. And lower resistance means more current. So in parallel, I should get brighter lights than when they were hooked in series. I'm just trying to get an extra wire that I need. So now we're coming off of these two light bulbs here, and we're going to connect back together and ultimately connect back to the battery. And hopefully this is brighter than the first arrangement was. There we go. So now we have them hooked in parallel. Electrons go through the green wire, they split, go through both here, which lowers the resistance as compared to when they were in series, and then returns back to here. So we have a lower resistance environment because they're in parallel. So qualitatively, based on these observations, we can see that the rules actually work, but now we want to test them with resistors. So I'm disconnecting everything here. We're going to get the light bulbs moved out of the way. We're actually not going to use the battery either. Put the wires to the side. What we're going to do is use the meter to read off the resistance of a couple of different combinations. So we're going to take two resistors and we're going to put them in series, check that they add correctly, put them in parallel, and then put one in series with two that are in parallel. and look at a combination of 3. So we'll just use like the first 3 resistors here that we see. So this should be a 100 ohm, but let's check it. So let's see what we have, what this one is. So our first resistor is 101.8. 101.8 ohms. That's this one. Set it right here. The next one, number 2, should be about 150 ohm resistor. $151.3. Okay, so now we want to check the series and parallel combinations of these 2 resistors and measure their resistance. It doesn't matter which order. I do need another wire to connect. So I'm going from this one into this one, and then back to the original. That would be a series combination. So I have a red into white into black back to the meter. And so together, in series, I'm at 200, and I've got a combination that's over 200, so I've got to go up a setting. And we get exactly 250. So in series, we expected 253 about, and we got 250. Not too bad. And then how about in parallel? Now we've got to switch the arrangement to be in parallel. So now we can imagine current flowing into this one, but now it has to split before it gets to the second one. So I have current that can go through this resistor, and then it could also go through this white wire to the other resistor. And then they can eventually come back here. So I can do this in a couple of ways. I could connect extra wires, or I can just clamp them together like this. Okay, so follow the red. The red is where you would think about the current coming through, and then it can split to go into the white, which would take it through this resistor path, or it can continue through this one, and they both end up in the black coming back to the meter. And we get an answer of 0.061, so I can actually go down to the smaller setting, and it's 61.2 ohms in parallel. Okay, last thing I wanted to do, let's turn it off for a second, disconnect everything so we can start fresh. So that's my 100, my 150, and let's take another one. Let's say this one's 560. Let's measure it directly so we know what the resistance is. And it's 560, so I'll put it on the 2 kilo ohm setting. Oh, see, this is what happens. This is actually a 100 ohm resistor in there. So this one was misidentified before. So we'll put it back in the 100 ohm bin, and we'll get an actual 560, hopefully. This is why you check. Okay, there we go. 548. So I'm just going to record this, 548, and the other ones were 102 and 151. Okay, so now what I'm going to do, so this is so the way I've labeled them on the Excel spreadsheet, this is R1, this is R2, and this is R3. And the combination we want to test is R1 is in series with R2 and R3, which are in parallel. So the current needs to go into R1. So So that's what it's doing here. It's going into R1, and then it's going to split at this point. Some of it will go to R2. So it's split to go to R2, and then also, use a different color. Some of it will go to R3. And then ultimately these need to come back together to connect to go back to the meter. So I'm just going to do that the same way I did before with parallel. I'm going to put these two ends together and clip onto both of them. Okay, so they look, I know it might look like a mess, but the red is going through this resistor. Then some current can go through the white, some can go through the yellow. The current that goes through the white goes through this resistor before getting to the black. The current that goes through the yellow goes through this resistor before getting to the black. And we get a total resistance in this combination of 218 ohms. Okay, so that's it. You can use these values to compare to what the theoretical should be on the spreadsheet and verify that series resistors add together, parallel resistors add as reciprocals, and then you can break down a more complicated circuit, like with 3 resistors, into a circuit that has a combination resistance. In this case, the combination resistance is 218 ohms.